Hello guys, so there is this issue that has caused a little bit of controversy in the JavaScript community that I find interesting, so I'm going to talk about it for a few minutes. So this issue here is called remove TypeScript, and they are removing all TypeScript code in the Turbo repository. So we don't need to know a lot about the repository, but what this entails. So if you read the article about why they're making this change, there's a quote that stood out to me here. So it says, TypeScript just gets in the way of that for me, not just because it requires an explicit compile step, but because it pollutes the code with type gymnastics that add ever so little joy to my development experience, and quite frequently considerable grief. Things that should be easy become hard, and things that are hard become any. So they're removing TypeScript from their repository, mostly because they think the extra compile step slows down their development. I think this is the second time I'm hearing about such a view from a large repository. So there's also a similar issue from the Svelte devs, where they're also switching from TypeScript internally to write pure JavaScript code with type annotations. So for them, they share the same sentiments that writing types for their code slowed them down because of the extra compile step and having to fight with the compiler. So what do they mean here by having an explicit compile step? So let's say you have a file here, app.js, that is going to be served in your app. So this file here is referenced in the index.html here and loaded in the browser. So let's say you have a variable name and you want to just print hello name, right? So this will be directly run in the browser without any compilation step. What if this app.js file was a TypeScript file? So let's say we rename it from a JS to a TS file, and we reference the same file here. So as you can see in the error here, the browser will refuse to load it because it doesn't understand the file type. To execute this as a JavaScript file, we need to compile it from TypeScript to JavaScript. So to compile this, you run TSE, which is the TypeScript compile, and then we give the TS. So as you can see, just from running that, TypeScript has already checked our file and has identified a couple of errors. So we fix the error and then we compile. So if you look at your file tree here, you can see there is an app.js file generated here. The TypeScript has been converted to JavaScript. So instead of loading this, we can now load the generated app.js file and the code will run. So every time we want to serve JavaScript to our users, we have to compile our TypeScript back to JavaScript. So you may ask yourself, why do you need the extra step when you could just write JavaScript from the start? So one of the main reasons people use TypeScript is to prevent runtime errors. So let me explain what runtime errors are. So let's say I have an object, an empty object, and I want to access a value in that object. Let's say object.foo.bar. So this is value JavaScript code and no error is being thrown here. And you're not compiling the code at all. We are shipping the code the way it is to the browser. But if you look at the browser window here, there's an error, unquote type error. Cannot read properties of undefined. We are reading bar. So this error will never be caught while you're writing your code. But once you ship the code to your user, that's when the code will throw an error. So the reason why TypeScript is used, because it can catch errors like this. So let's say we convert this to a TypeScript file. So immediately you can see that TypeScript has already put a red underline under the code and shown you the error. So immediately, even before shipping the code to your browser, you already know that something is wrong with this code. So you have to fix it in order to ship it. If you try to compile this code with TSC, let's say we run TSC or app.ts. So the code will compile regardless of the error and will emit the file for you. To prevent you from shipping code with the runtime errors, you can prevent the compiler from emitting any of these files if errors are detected in it. So you can do that by adding a jsconfig.json file. So inside it, you can have compiler options and we say no emit on error true. So it won't emit any code if there's an error. We can also set the output here to maybe list and then try running the compiler again. So we can run the compiler by running tse file there and it will automatically use our tsconfig. And as you can see, no files have been added to the file tree and you can see the errors that your file has here. So until you fix this error, no file will be emitted. So you'll have to go back there to the file and fix the error and then run the compiler and the file will be omitted. So you can just point to the list folder and you can see our code will now run successfully. So that's just a simplification of what TypeScript does for a development process. So Svelte switched from TypeScript internally because they didn't find it that efficient for them because of that extra compile step. But what they did is they switched from using TypeScript to using JSDoc. So if you look at their JavaScript code, they have JSDoc annotations in their code. So these JSDoc annotations allow JavaScript code to have types without really using TypeScript. So let's say you have a function that says prints name, and then you have the first and last. It returns, just concatenates first and last name. So if you call this function, you can see that the first and the last name here, you don't know what the types are going to be, but we can add annotations to these functions that adds type to the parameters. So you can say the first name is a string and the last name is a string, and you can also say that it returns a string. If you hover over the function name, you can see now the types directly reflected here. Since the editor knows that this returns a string, you can call string methods directly on the output of that function and you'll get edit autocomplete. So if you don't want to use TypeScript directly, you can use JSDoc annotations and they will work out of the box in your editor. The problem with this approach is that the annotations are not enforceable, right? So you say it returns a string, but you can also say it returns a number and no errors will be thrown. So you can call methods that are available on the number object, like to exponential, and no errors will be thrown. Let's try to run this and see how it works. So again, you get a runtime error. If these were TypeScript, you can see even with the type annotations that we are using here, TypeScript will still throw an error because it infers the return type of this function, that it returns a string and you're trying to call a number method on it. So how does SvelteKit overcome this annotation issue? Let's find out. So if you look at their project, you can see that they're still using TypeScript to check their files, their JavaScript files, and they're using the no emit option here, which means that the files are not compiled. So it's just checking the types to make sure everything is working. And then another interesting thing here is that if you look at their tsconfig, so they allow checking of their JavaScript files via the allow.js and check.js options set to true, and also the no emit on error set to true. So in their tsconfig, they have the allow.js and check.js option. So that means when I run the compiler, it will check this JavaScript file. So we provided the wrong return here that returns a number and then returned a string anyway. And you can see that TypeScript has caught that error and told us that the type string is not assignable to number. So if we return the correct type here, TypeScript should catch that and throw an error from this to exponential call here. Let's try it. So you can see the next error here is property to exponential does not exist on type string. So TypeScript has helped us identify this error, but JS couldn't identify it. So we had to run it on the browser to be able to get the runtime error. If we change this to call a string method, like say to uppercase, and then run the compiler and look at the generated file, the file has been generated and the correct code is emitted. So even when we are writing vanilla JavaScript code, TypeScript is still very important to be able to identify errors that we wouldn't identify if we wrongly type our code or if we called the wrong methods in our code. Even if you don't want to emit any of this code and you want to load this directly, we can still use the no emit option like Svelte are doing and still be able to see our errors before we push them to production. So if we say go back to the wrong code and try running it again, it won't emit, but we'll be able to see the errors that our code has. Another interesting thing that I caught in this Svelte code base is this generate d.ts script here. So what this does, it reads all the JavaScript code and looks at the JSDoc annotations and generates a d.ts file for those annotations. So this is important for their user-facing API. Let's look at an example of a d.ts file that they have generated, like these interfaces.d.ts. So these are TypeScript types and they ship their library with this. Either if you use TypeScript or don't use TypeScript, you'll be able to get access to these types. A good example of that is let's say you want to create a new Next.js app. So npx create next app. Let's call it example, and you want to use TypeScript, Tailwind. Let's say no to everything. Let's open this example app. So one thing you notice from this newly generated app is that the types are automatically inferred by our editor and you're not using any TypeScript. So for example, you know all the props that the image component accepts. So let's say if you type width, for example, you immediately get editor autocomplete that this component accepts width, and if you type height, you get automatic editor autocomplete for the type. So this is because the Next.js package ships with types inbuilt. So these types are used by the editor for the autocomplete function. So if you pick the type definitions for this image component, for example, you can see that the types are being loaded from the image component.d.ts file. So this file is very important for the editor to be able to autocomplete the types and check if you are providing the correct props for your types. But also, if you provide the wrong props and you say provide a random prop, to the component, the editor won't show any errors. So to be able to get editor errors if you provide the wrong types to the component, there is a jsconfig option here that you can use. It's like tsconfig but for JavaScript, and you add the same options you would add to a tsconfig file. So if you add check.js, for example, you can see that automatically the errors have been highlighted for your component, but now you're getting errors in the whole component because it's not recognizing the JSX. So another option you can add, JSX React JSX. So this option should allow type checking to work for React components. So you can see the error is properly highlighted for us. So that's it. If you want to use JavaScript but still want type annotations from TypeScript, this is the correct approach to take. So either have a tsconfig file to allow type checking of your JavaScript files, and also make sure to run the TypeScript type checker with the no emit flag so that you can see the errors while you're coding, even without having to compile the code. If you go with the approach of having to remove TypeScript completely, you'll have to deal with a lot of runtime errors and your users not knowing the API, especially if you're a public library that people install in their code base. Either write a separate d.ts file for your project, check with the TSC no emit flag, or add JSDoc annotations. Add some sort of typing to be able to catch most of these errors before pushing them to your users in production. So thank you for watching and see you in the next video.